Alright, hi Year 11, this is Mr. Lim here again, and this is our second last video on atomic structure about trends across the periodic table. Let's get started. Okay, so we're going to be learning about the trends across the periodic table, which means that we're going to be learning about how it's arranged and then the ways that characteristics change over as you go left and right or up and down the periodic table. Alright, so let's have a look. Structure of the atoms to characteristics. So the idea is that the structure of the nucleus, which means the number of protons and neutrons, and the arrangement of the electrons, which is all the videos that we've been learning about before, around it determine the properties of the atom of an element. Okay, so it's the structure and arrangement. Structure of the nucleus and the arrangement of the electrons. They determine the properties of an element. And so, since the periodic table is arranged by increasing number of protons, so going from one proton to, lots of protons, and the arrangement of electrons, so we talked about that in the orbital arrangement, where we've got the s orbitals, the p orbitals, the d orbitals, and the f orbitals, and the s, p, d, f blocks, right? There are certain characteristics that change predictably across, that means up, left and right, and up and down as well, the periodic table. All right, so characteristics, because they're arranged by protons, which is the structure of the nucleus, and the arrangement of the electrons, there are characteristics that change predictably, which we call trends across the periodic table. All right, so the four main characteristics that change predictably across the periodic table are atomic radius, which is, the radius of the atom, electronegativity, which is the amount of pull that the nucleus has on shared electrons, okay? So it's effectively pull, like an electrostatic attraction between a positive and negative thing. The nucleus, which is the positive thing, has on shared electrons, which are the negative things. So effectively, how well can the nucleus pull electrons? First, ionization energy. So this is the amount of energy required to remove, required, and that word required is so important, to remove 1 mole, and don't worry about 1 mole at the moment. 1 mole is just like saying 1 dozen of something. A mole is a word that describes a number, right? Of electrons from 1 mole of atoms. So effectively, how much energy it takes to remove the first electron from the atom. And then finally, metallic properties. Okay, so how metallic the substances are. So metals have a certain characteristics, and so therefore how metallic that substance is like its metallic properties. All right, so let's go on. Those four main characteristics are determined by a couple of structural aspects of the atoms. All right. First is being the core charge, which is the net overall positive charge attracting the outermost electrons. Okay, and the outermost electrons can sometimes be called the valence electrons. Valence being a word to describe the outermost stuff. Okay, so the idea is that it's the positive charge attracting the outer electrons, okay? And it's the net overall. What does this word net mean? It means it's we take into account some positives and some negatives, okay? So the electrons in the inner shells shield the electrons in the outer shell from experiencing the positive charge from the nucleus so that they are attracted less. Okay, so what does that mean? Let's just say here is the nucleus and it's positively charged, right? And let's say it's a 3 positively charged, so there's 3 protons there. That makes it an atom of lithium, okay? There are 2 electrons in the first shell, all right? 2 electrons in the first shell and another electron in the second shell, okay? Or the energy levels. So the idea is that this electron here is experiencing what's effectively a net positive 1 charge from those things inside the yellow circle. Okay, there's 3 positives and 2 negatives make a 1 positive. So that is experiencing an attraction between a positive 1 and a negative 1. Okay, so that's the idea of core charge. It's the charge that you end up after when you have the positives, all the positives from nucleus, subtract all the electrons not in outer shell. And I've probably written that in this part here. Okay, So core charge increases further to the right of the periodic table and stays constant up and down the periodic table. Okay, so effectively, your periodic table looks like this. Okay. Yep. Okay, and so as it goes this way, the core charge increases. Okay, but as you go up and down, the core charge stays constant. Okay, that's what it's saying. Up and down stays constant. Towards the right, the core charge increases. Okay. Why is that? It's because the core charge is calculated like this. Core charge is the number of protons subtract the number of electrons that are not in the highest energy level, which means they're not in the outermost shell, right? So the core charge is the number of protons, which is the center part, the number of protons in the nucleus, subtract the number of electrons that are not in the highest energy level, right? So we were to work out the core charge of fluorine, which happens to be here on the periodic table compared to the core charge of lithium and fluorine. Lithium we just worked out. Lithium would be +1. Fluorine, if we think about fluorine, has a net, the positive in the middles is +9. Yeah, 9, okay? And then it has 2 electrons in the first shell, and then 7 electrons in the next shell, or the next energy level. Okay, so these ones here in this thing here shield some of that positive charge, but it still ends up being +7. Okay, and so each of these electrons here experience a +7 attraction to this green effective net overall charge, right? So that's why the core charge increases as it goes towards the right, but stays constant up and down. Okay, oops, didn't mean to do that. Okay, the number of electron energy levels is that's the core charge concept. The number of electron energy levels is effectively saying that the more energy levels there are, so how many of the energy levels there are, so like, whether it has electrons in the first energy level only, or in the first and the second, or in the first and the second and the third, that's the number of energy levels, right? The more energy levels there are, the further away those electrons are from the nucleus, and thus it affects their properties, and the number of energy levels increases further down the periodic table, okay, but stays constant left and right across the periodic table. Okay, so that's what we need to remember about the structure of the atom. Core charge increases towards the right, number of electron energy levels increases down the periodic table, but then they stay constant going the opposite in the perpendicular direction. Okay, so let's move on. Let's go look at how the property is affected by the structure. Okay, so the higher the core charge, the smaller the atomic radius. Okay, this is the relationship between the atomic radius and the core charge. Let's have a think about why. This is because there's an increased attraction between the positive unshielded charges, that's the overall core charge, and the negative electrons. Okay, so there's that increased attraction, means that they pull them in closer. That means it makes it smaller atomic radius. The higher the number of energy levels, okay, so the more energy levels you have, and remember all of those energy levels, they get further away. That means that the atomic radius increases, the larger the atomic radius. Okay, why? Higher energy levels need to be further away from the nucleus, and therefore the radius gets bigger. All right? So, atomic radius, those are the relationships. You just have to memorize those. Okay, let's move on. Let's talk about electronegativity. Okay, so electronegativity is the property. We have to look at the structure. The higher the core charge, okay, so that's the more positive the center part is, the higher the electronegativity. And that makes sense. The higher the positive is, the stronger that they can pull on electrons, right? So this is due to increased attraction between the positively unshielded charges and the negative shared electrons. Okay, so effectively, the higher the core charge, the higher the electronegativity. All right. However, when the p orbital is full, i.e. the group 18 noble gases, the electronegativity drops to nothing. Okay, because it doesn't really need to bond with other elements. It doesn't attract any shared electrons. Okay, so it's effectively saying, I've had enough. Those outer electrons shield the inner parts fairly well. Okay. However, then we have the higher the number of energy levels, the lower the electronegativity. So remember, electronegativity is the pulling power of the nucleus. If those electrons, because they're at a higher energy number level, that means that they're further away. Okay, since they're further away, they have lower attraction because this electrostatic attraction doesn't work very well over long distances. So the further away it is, the less of an attraction that there is to it, which means that there's a lower electronegativity. Okay, let's move on. First, ionization energy is the property. We have to look at the structural element. The higher the core charge, the higher the first ionization energy. And that makes sense. Higher the core charge is, effectively the more positive it is. And if it's more positive, it's harder to pull away any negative things from it. So if you increase the traction between the positive unshielded charges and the outermost electrons, that means more energy is required, and that word required is so important, to remove the electrons when there is a larger attraction. Okay? The higher the number of energy levels, that means, again, they're further away. And if they're further away, do you think they'll be easier or harder to remove? They'll be easier to remove. Okay? So that's why, because they're due to increased distance between the outermost electrons and the nucleus. Okay, and then you need less energy to remove those electrons. Okay? And then finally, metallic properties. Now, metallic properties don't really have ways to describe them. They're just how metallic something is, which means that they conduct electricity or they're malleable, things like that. We'll be learning about metallic properties later. But the idea is that the higher the core charge, the lower the metallic properties. Okay? That's why as you move towards the right of the periodic table, they become less metallic, right? The higher the number of energy levels that's going down the periodic table, the higher the metallic properties, okay? So that's why, if you remember on a periodic table, okay, that's why, you know how there's this kind of funny squiggly line here to define that these are non-metals? Hopefully we've gone through that in lower school. And these ones over here are metals. That's because here they have a high core charge, and here they have a low core charge. But remember, down here, they also have a low core charge because the electrons are quite far away. Not that they don't have a low core charge, they just have a low amount of attraction between this is not core charge, this is going to be number of shells. High number of shells. Okay, because they have a high number of shells in this area, that means they have a higher rate of metallic properties, which is why elements in group 14, starting with carbon at the top and then lead at the bottom, lead is a metal, but carbon is a non-metal. Because lead has many more, even though they share the same core charge, lead has many more energy levels than carbon and therefore is more metallic. Okay, generally metals have low that's not what I wanted. Generally metals have lower electronegativity, and that low electronegativity produces metallic properties. Okay, and so those are the trends across the periodic table. You're going to have to memorize their relationships to each other and their core charge and number of energy levels, and then be able to predict from its position on the periodic table which one has higher electronegativity or which one has a larger atomic radius if when given two particular elements on the periodic table. All right, we'll be practicing that in class, and so that's that. Adios.